Dear participants, dear organizers of conference, thank you very much for the possibility to present our research regarding flame retardants for biodegradable polymers. This research is being conducted at the Institute of Macromolecular Chemistry of the NASA of Ukraine in the Department of Polymer Modification under the supervision of Professor Dr. Sergei Riabov. So let me start. Polymeric materials are all around us, and we are increasingly using biodegradable polymers in our everyday life, particularly for the renewal and decoration of our houses. Ensuring fire resistance has become especially important nowadays, when the number of destructions and fires has increased as a result of aggression against Ukraine, and in particular as a result of enemy attacks. In order of reduce fire risks and ensure the possibility of widespread use of structural materials based on polylactic acid for the restoration of destroyed homes. It is necessary to solve the urgent task of developing a new effective and ecological fire retardants. What are the solutions? Halogenated flame retardants, HFR, are a broad class of chemical compounds that contain one or more halogen elements, primarily bromine, brominated flame retardants, BFR, or chlorine. They are added to a wide range of materials to inhibit or slow the spread of fire. HFR primarily work in the gas phase on a fire. When heated, they decompose and release halogen radicals like bromine or chlorine free radicals. These radicals react with the highly reactive hydrogen and hydroxyl radicals that are crucial for sustaining combustion. HFR effectively disrupt the radical chain reactions that fuel the flame, thereby slowing down or preventing the fire from becoming established. Despite their effectiveness in fire retardation, HFR have become a significant concern due to their potential adverse health effects. What we can use instead of HFR? Organophosphorus flame retardants are a diverse group of synthetic chemicals that contain phosphorus and carbon. These FRs are used as a replacement of HFR, halogenated for flame retardant, due to the problems with toxicity. Organophosphorus flame retardants are widely used in modification of various polymer materials for improving its fire safety. Main types of organophosphorus compounds used as flame retardants are the follows: phosphate esters. These are the most common type of organophosphorus flame retardants that are derivatives of phosphoric acid. Phosphonates, organophosphorus heterocyclic compounds, and oligomeric organophosphorus flame retardants. How this type of flame retardants works? Organophosphorus flame retardants primarily exert their flame retardant effect through a combination of gas phase and condensed phase mechanisms. Condensed phase action, when exposed to heat or BFR, decompose to form phosphoric acid and polyphosphoric acid. This acid act as dehydrating agents promotion the formation of char layer on the surface of the burning material. This char layer acts as a barrier, insulating the underlying material from heat and oxygen. Gas phase action, some OPFR can also release non-combustible gases into the flame. These gases dilute the flammable gases and can interfere with the radical reaction that sustain the flame. Amine-containing FR. The FR effect of phosphorus, nitrogen, PN compounds in many cases is attributed to PN synergism. It is believed that this effect encourages the cross-linking of polymeric chains during the thermal decomposition process. It boosts the retention of phosphorus in the condensed phase and produces thermally stable char. The performances of DOPA in H2FR can be effective for using with PLA that may be due to the formation of a hydrogen bond between amino groups in the structure of DOPA NH2 and the carboxyl end group of PLA. The changes in mechanical properties of PLA after its modification of the DOPA NH2 FR needs be additionally researched now. How does it work in practice? The new organophosphorus FR has been synthesized by us. And in the next step, this FR was implemented to the polymer matrix of PLA for flammability testing. In this photo, you can see two materials, material without FR and material with our new FR. The polymeric material was subjected to a special test like UL94, and the result was that a significant slowdown in combustion was observed. Also, we revealed the self-extinguishing combustion, charring, and the absence of droplets of the material with FR compared to the unmodified material. And our next step with our new FR, as the next step, we are planning to improve the application of synthesized FR as to improve its solubility, with the goal of evenly distributing FR in the polymer matrix, and also changes in mechanical properties of PLA after its modification of the DOPA NH2 FR needs be additionally researched. Thank you for your attention. Thank you
for your interesting presentation. Any questions? We have no questions. Thank you again.
Thank you very much.